Howdy there. So this time I'm going to give you a bit of a refresher on statistics as summary, as in summary statistics and whatnot. So the major goal of statistics is to organize and summarize. It's to transform a pile of numbers into something with meaning. And this can be with distribution of a variable in a table or graphs showing like the categories of some outcome, values of that outcome and frequency, as well as just percentage of occurrence. There are tons of ways to describe these numbers, but we need some way to get a handle on them because otherwise we'll be just overwhelmed by just piles and piles of data. So, we can summarize them with descriptive statistics. So we're talking like we can do tables. Like I've produced this really cool one from 1845 to show the population of the world. I've also included some graphs here that I've animated, which I thought was cool because I want to figure out how to do it. And summary statistics, those numbers that summarize other numbers. Now, again, summarizing is all about description, but with other numbers. There are hundreds of descriptive statistics, and I'm going to give you kind of a framework of how to think about them. And then I'll talk about our classic three. But the goal is to describe the whole pile of data with a single number. And we can do this with this broad framework, this taxonomy. So the first way to describe is measures of central tendency. So these are location. Next, we have, and I'll crawl deeply into this on future slides. Next, we have spread, which is how spread apart, how much space there is amongst our numbers. And lastly, skew. So the distribution, is it balanced? Is it tilted? Like this shape. Those are where we're going. So one way to illustrate your data is with a histogram. A histogram is a graphical representation of the distribution of numerical data. It approximates a probability distribution. This type of graph was first described as recently as 1895 by Carl Pearson, who we've seen elsewhere. And I've got his version on the next slide. Sorry, it's not the best resolution, but it's a way to illustrate data. And it does approximate the shape, as you can see with a nice overlay. The tighter your bins, so the smaller each bin is, the more normal, or the closer to your probability distribution it looks. Alright, so here is a stem and leaf plot. This is also called a stem and leaf diagram, and it here illustrates plot of outdoor education effect sizes. It's straight from a classic book called Exploratory and Graphical Data Analysis by John Tukey. But my point is that you can show data pretty interestingly and get a good sense. However, we can't always convey with a picture. So, how do we do it with a number? So, location. So, the three most common measures of central tendency, so that's where the bulk of the data live, are mean, median, and mode. And I've got some equations coming up for those of you who need them, but the idea is that they show you where the center of the data are. So the mean is, well, it's the arithmetic average, usually. The median is the cut point where half your data are above that value and half your data are below that value. And mode is the most frequent value in your data. In theory, if you have normally distributed data, those values should be straight on top of each other. It shouldn't make a difference. And as you can see in this R illustration, that when you change the mean, you shift the distribution. So that black one in the middle has a mean of 0, while shifting right means the mean is increasing, shifting left is the mean is decreasing. Now, variability is our next descriptive statistic. Variability describes how spread out the data are from that center. Low variance means that the data are more tightly packed together. More of their data, more of their mass is in the middle. High variance means that the bulk of your data, while still around the center, is more spread out, as illustrated in these figures. So highly variable data, more space. Low variable data, less space. They still have the same amount, and the means are the same, but it widens your data. So skewness is our last one, and skewness is a measure of symmetry, or more precisely, a lack of it. So a distribution or data set is symmetric if it looks the same on the left and the right. Can you fold it in half, so to speak? Now, positively skewed data, or right skewed data, is where the bulk of the data is on the left. So wherever the tail is, that's where the name is. Negatively skewed or left skewed data means the bulk is on the right, while the tail is on the left. Now, the cool thing is that, as I mentioned earlier, mean, median, and mode are the same if you have symmetric data. So if it's balanced. However, when you have asymmetric data, you can actually, depending on how the mean, median, and mode are situated, that can tell you a lot about your data. Now, for left skewed data, the mode is the largest and the mean is the smallest because the mean is more sensitive to outliers, so it gets pulled closest to the tail. The median's in between the two. For right skewed data, it's the reverse. Mode is the smallest number, mean is the biggest number, and it's closest to the tail. Now, how the hell are you supposed to remember that? And I find it very challenging because right skewed, left skewed, positive skew, all that, it's not intuitive to me. So here's the cutesy thing, and I kid you not, this is how I think about it, is the cowardly skier. So whichever direction the cowardly skier would go is the direction is how you name the skew. So the cowardly skier on a right skewed data set is going to go towards the left. It's going to go towards the less steep side. So for positive skew. Now the left skewed means he's going to go to the right. Yeah, sorry, I'm hesitating now, but follow the illustration. So left skew, the mean is the smallest, median's in the middle, mode's the biggest. Right skew, mode is the smallest, mean is the biggest. Yeah. So yeah. So that's it for statistics as summary. For those of you who needed this little refresher, it's okay. It's been a while. Yeah, okay.